All right, so first things first. On your Canvas homepage, a very nice looking one. So between the big blocks and the weeks, you see a purple line there that says attendance verification, syllabus, apps to download, and grade calculator. So, the grade calculator. The grade calculator. The grade calculator. And again, we have no video. All right, so the grade calculator. If you click on the grade calculator, you will see that there's 3 of them. One's after exam 2, one's after exam 3, one is after exam 4. And I want you guys to notice the note on it says to download and open in Excel. Okay? If you don't download it and open in Excel, it doesn't work. So if you click on here right now, after exam 2, there's nothing to manipulate. You can't manipulate anything here. Okay? You're going to see 2 tabs on top, which when you open Excel will be the 2 tabs on the bottom. One says if you took both exams, and the other one says if you missed an exam. So some of you guys have taken both exam 1 and exam 2. Some of you guys only took exam 1 but not exam 2, or took exam 2 but not exam and missed exam 1. Okay? So there are 4 steps here. Step 1 is down here. Step 2, step 3, step 4. Okay? All step 1 is saying, hey, in case if you miss one of the exams, you're in the wrong tab. And the other tab just says, hey, if you took both exams, you're in the wrong tab. Okay? So pick the right tab. Step 2, you ought to pick the final grade that you desire numerically. So if you want a C, I would recommend not using 70, but using 72. B, 82. A, 92. Okay? Step 3, you are to put in your MLM average, your lab work average, exam 1 and exam 2, which you can find all of that in your Canvas gradebook. Right? The average is all the way to the bottom where it's bold. Those are your averages, and then exam 1, exam 2, you'll have to scroll up a little bit, and you'll see those. All right? Once you plug those in the big fat yellow box in the step 4 is what grade you have to average in exam 3, exam 4, and the final exam to get the grade that you want. Okay? Assuming that your MLM average stays the same and your lab work average stays the same. Okay? So, and if this yellow box turns red or is over 100%, that means you can't get that grade. So you try to put a 92 in there, and this turns to be like 110, you won't be able to get that grade. You can't get an A. Okay? However, I also want you guys to manipulate the MLM average and the lab work average, because if you currently have a 50% in MLM, and since I reopened everything in MLM since the beginning of the class, you might want to try and see, hey, what would I be able to do it if it's 100%? And if you are, then maybe it would light a fire under your butt to say, hey, I better go back in before it closes this Saturday and get everything to 100%. Okay? So that is the 4 steps. And then in this white box here is what your current grade is in the class. Now, that might agree or disagree with Canvas, just so you guys know. Okay? But that is your current grade. Okay? So I would tell you that this weekend, feel free to do that. Now, for your class, since nothing is changing, everything's staying put, that means exam 3 is next week. You guys are lucky because that means you're going to have 3 exams under your belt. And then you can open up the grade book after exam 3, or the grade calculator after exam 3. And you guys can say, okay, how am I doing in this class? Can I get those grades for exam 4 in the final exam to decide if you should withdraw or stay in the class? Okay? So that is, of course, up to you. Any questions on that part? Pretty clear? You do have to open in Excel. If you don't, it won't work. All right, so on Tuesday we talked about parabolas, right? We learned some new words, the focus. We learned the directrix, and we also learned the latus rectum. The parabola is the only one that's going to have a directrix and also the only one that's going to have a latus rectum. Okay? So we won't be able to have fun with the word rectum anymore for the rest of these two sections. Ellipse, however, will have two foci, meaning two focuses or two foci. Okay? So, however, the ellipse has an A length, a B length, and a C length. So the whole purpose of the foci is that if I was to attach a string to two thumbtacks, I can draw that ellipse. Okay. So if you notice that there's a major axis and a minor axis. The major axis is the side that is going to be longer. The minor axis is where it's going to be shorter. Okay? And because there are two foci, there's also going to be two vertices. And on the minor axis, that point doesn't have a name. Okay? It's just the distance of B. So the A is the distance from the center to the vertices. B is the distance from the center to the edge of the minor axis. And C is the distance from the center to the focus, or to the foci. And the relationship between A, B, and C is this. C squared is going to equal to A squared minus B squared. Now, just like the parabola, we talked about first if the center was at, with the parabola, we talked about when the vertex was at 0, 0, what happens to the equation. So with ellipse, we're going to talk about where the center is. If the center is at 0, 0, what the equation is going to look like versus when it's not in the center or at 0, 0. So here is what happens when it's at 0, 0. There's your focus. Your vertices is A. From the center to the vertices is A. Center to the focus is C. And then to the minor axis edge is B. So you'll have x squared over a squared plus y squared over b squared equals 1. This is an easy equation to remember because a circle, an equation for a circle is x squared plus y squared. Right? So we can remember that as, because a circle is just, an ellipse is just a circle that is just flattened out, right? Either one direction or the other. So it's still going to be x is squared, y is squared, and it's going to be addition. Okay? Now, if you look at this picture here, you see that the distance of A is a lot longer than the distance of B. Everybody see that? So if you want to know if it's more this way or more this way, it's dependent on what A is under. If A is under the X, then it's more long ways along the X-axis. If the A was under the Y, then it's going to be longer along the Y-axis. So it's going to be more like this, okay, versus this. So you see that right here. So this is still the center is at 0, 0. Notice that the A squared is now under the Y squared. And notice that this ellipse is more elongated in the Y direction. Where when the A squared is under the X squared, it is more elongated in the X direction. The relationship of A squared, B squared, and C squared is still the same. C squared is still equal to A squared minus B squared. And the A, B, and C is very important here. And of course, if it's not in the center, we're still going to use H and K for the center. So the X squared would just be X minus H squared, and the Y squared would just become Y minus K squared. Same idea. So you'll see those formulas right here. Again, because the A squared is under the X squared, it's going to be elongated towards the X direction. If the A squared is under the Y squared, then it's going to be elongated towards the Y direction. And yes, this will be the table that you're probably going to see as your cheat sheet and nothing else. So if you notice that in this case right here, it's talking about how the center is not at 0, 0. That's why it's those equations, but it also still tells you what the relationship is, which is really the same formula as C squared is equal to A squared minus B squared. Any questions so far? So are we ready for some examples? Because just information just doesn't really add up until we actually do examples, right? So where's my center? Hello? Yes?
We can find the square roots of 39 and 40.
True.
So that would result in.
But again, let's answer my question first. Where's the center?
Oh wait, the center is at 0,
0, 0. Awesome. Because there's no H or K attached to the X squared, right? And the Y squared. Awesome. Is this going to be elongated this way or this way? Along the X or along the Y? Is it elongated along the X or the Y? X. Why? Because the larger number is under the X squared. Okay? So because of this, right? So it must elongate in that direction. Make sense? Which, since that's a larger number, it must mean that also that a squared is equal to 49. So a is going to equal to what? 7. Beautiful. Then what is this smaller number going to mean? So which is which distance? Thank you. So b squared is equal to 4. So b must equal to 2. Okay. So your first instinct is to say, let's plot it. Right? That's your first instinct. You're saying, I know b is 2, so 1, there's 2, and 7, 2, 4, 6, 7, 2, 4, 6, 7. Now I can draw this. Come on. Come on. Oh gosh, this is so hard to do. Hey, there we go. So what are we missing here? We're missing C because it wants to know the center, the vertices, the foci, right? In order to get the foci, we need to get to C. Okay, so what's C squared equal to? Awesome. So C squared is equal to 49 minus 4. So C squared is equal to 45. So C is equal to what? Square root of 45, which we can reduce that as plus and minus 3 square root of 5, which is approximately plus or minus 6.7. So the decimal aspect of it is for us to graph, right, somewhere close. But the 3 square root of 5 is for us to actually name the points, right? So 6.7 is about right here. Well, a little bit closer, but we'll just call it there. And negative 6.7. So let's go ahead and name them. So we know the center is at 0, 0. Where are the vertices? Why is it negative 4, 0? Why is it here and here? So you're trying to say 7, 0 and negative 7, 0. So essentially, this has everything to do with what we did with the red. Right? How about the foci? Where are the foci located? Hello?
Negative 6.7, 0, and then it's positive 6.7, 0.
That's where the radical needs to come into play.
Okay.
That's why I get to the decimal only for my plotting, but the radical has to be part of the answer. So I guess I would do this. Let me do this. Let's change that color to purple so that I can change this color to purple. So we know where all of these numbers come from. Notice that the B is only to help us graph, right? It had nothing to do with anything we're looking for. Questions? So when it's asking you to find the center and the vertices and the foci, it is for us to actually name them, name those points. Okay. No questions. Ask whatever you guys want. I'm good. Nothing? Yep. Yep. Okay. So once we determine if it goes in this direction, if it goes in the x direction or the y direction, okay, the long points are going to be your vertices. So notice that the foci, the vertices, and the center is along the same line on the major. On the minor, it's going to be your B's. So your B is always going to be based on your shorter length. Okay? And it's only used to just graph of how thick that thing is.
And is it opposite if the graph is?
Correct. If it's the other way, if it's elongated long ways, right? Well, we'll use this as, as a really bad example, right? So if it goes this way, then this is a major. So my vertices, foci, center, foci, vertices, and then these two sides here would be my B. If it's this way, same thing, that would be my major, vertices, foci, center, foci, vertices, and these would be my B. Cool? Any other questions? I swear I saw a second hand raise.
I had a question about the vertices.
Okay.
So, like, how did you get that, like, exactly?
So the vertices is the ends, right? So what we said in the very beginning is that that distance from the center to the vertices is what value? Do you remember? So up here, so from the center to the vertices is a distance of A, okay? Which is already part of our equation. So the A and the B is always going to be in the equation, okay? So if the A is under the x squared, that means it's got to elongate in the x direction. If it's under the y squared, then it's going to elongate along the y directions. And the way we know which one is A is if it's a larger number. Okay? Make sense? Okay? And that's the reason why when you look at this, when you like go back in the notes, like after I post them, I want you to make sure that you see the red with the red, the blue with the blue, right? And then the purple with the purple. Okay? I guess I should have done this as purple too then. Right? So this way you can see exactly what those came from. Cool? All right. Any other questions? We good? All right. So this one says, analyze the equation, that is, find the center, foci, and vertices of the ellipse. Wait a minute. I thought the equation for the ellipse was a fraction. This is not a fraction. What the? But I do see x is squared and y is squared, right? And it's addition. So it must be a circle or ellipse of some sort, right? How the heck am I going to deal with this? What does CTS mean?
Complete the square.
Complete the square. Because if you look at the equation, we have a bunch of y's, we got an x, right? So we have 12x squared plus y squared plus 12y is equal to 0. Are we okay there? Because notice that it was some kind of quantity y squared in my ellipse. Quantity of x squared. But there's only one x, so I don't have to worry about that trying to make it a quantity squared. So I need to find a new c. And what's that equation for c again? No. For completing the square. Wasn't it b divided by 2 squared? And what's my b here? 12. And I always tell you to do the work. And it's going to be 6 squared, and that's going to equal to 36. Agreed? We're okay there? So that means I'm going to add 36 to this side and add 36 to this side. Yes? Question so far? So that means I have a 12x squared plus y plus 6 squared equals to 36. Does everybody see that? Because I have to factor this now, right? And the factoring is already done. That's why I tell you to show the work. Because if I do the work, then the factoring is already done for me. Cool? Awesome. Ladies and gentlemen, we still have a problem.
Do we need to divide by 36 on both sides?
So the question that people are going to ask is, do we divide by 12 or do we divide by 36? Why did you choose to divide by 36?
Because if we divide by 36, we get it to equal 1.
Correct. So if you look at the ellipse equation, it was x squared over a squared plus y squared over b squared is equal to 1. So we need the other side to equal to 1. So we need to divide everything by 36. So when I divide everything by 36, I'm going to have x squared over, thank you, plus y plus 6 squared over is equal to 1. That looks way better. Yes?
Why can't you divide both sides by 12 and then divide both sides by 3?
I guess you could, because you're still dividing by 36. Because you divide by 12 and divide by 3, you're dividing by 36. Right? Because 3 times 12 is 36. So you can do that. Because you essentially divide by 3 again because the right side wasn't equal to 1 yet. So you're like, okay, I got to get rid of that. So if you happen to divide by 3, you're not doing anything wrong unless you stay with it. But once you make the realization of, oh, crap, the right side needs to be 1, let me divide by 3, that's certainly fine. I don't have a problem with that whatsoever. This is just a shortcut, I guess. All right, so center. No.
0, -6.
Does that make sense? Because remember, this is 0 because h has to be 0. What's k? But really the h is here. It just happens to be 0. Because I wouldn't write x minus 0 quantity squared, right? I wouldn't write that. Which way does this go? Towards the x direction or the y direction?
Towards the y direction.
Y direction. Right? We know that it goes in that direction. And it's all because of this number. So I know that a squared is equal to 36. So a is equal to 6. Right? That is my vertices. All right? So this right here is my b squared. So b is going to equal to square root of 3, which is approximately what? 1.7? Is that right? Someone check me. I have no idea. Yeah? Okay. So from here I can graph 0, negative 6. 0, negative 6. 2, 4, 6. There's my center. My vertices is 6 away, so go up 2, 4, 6. There's my vertice. Down 2, 4, 6. There's my other vertice. My b is about 1.7. Hey, come on. Hey. I wish there was a different way of doing this. There we go. What am I missing? And that's equal to? What is that approximately? Oh, 5.7? Okay, so I have the center at 0, negative 6. Where are my vertices? Very good. Thank you. And ¿dónde está mi foci? In radical form. Come on now. Radical form, come on. Correct, correct. I mean, I can't break down square root of 33, correct. The problem is still finding what this is and what this is, right? Because the square root of 33 is the distance from the center to the foci. So what would those 2 points be? Here, I'll help you guys out. Did that help? Let me get your x value for you. 0. What is it? What do you think it was? Yeah, because if it was positive square root of 33, it would be up here somewhere. And then negative square root of 33 would be right here. Both. Again, this distance right here is square root of 33, right? So this distance would be negative 6 minus square root of 33. And this distance here is square root of 33, so I would take the negative 6 and add square root of 33. And you'll get that 0.3 if you tried it out, or 0.26 or something like that. Did that confuse anybody? Any questions on this? None? We're good to go? Are we sure? So we're ready for the hyperbola. All right. No. Like, dang it. I know. It's like, I almost want to play with more examples. Well, here's the good news. I think your lab work is going to have some. Quite a bit, I think. I think I took more of lab work 9 than lab work 8. Okay. Oh, no, actually, no. Yours is just regular. Yours is just lab work 9. So you guys didn't have a mixture. All right, hyperbola. Again, you're going to have a foci. You will have a center. Now, they call this the transverse axes and the conjugate axis. I'm still going to call it the major axis and the minor axis. Okay? So the major is your transversal, or your transverse. So your major axis is still going to have your foci, your vertices, and your center. Okay? Which is where your A and C still lives. And your B is on the other sense. So A is still the distance from your center to your vertice. I'm going to go C is equal to the distance of your center to your focus. And not D. B is equal to the distance to center to, I don't even know what to call B. I'll leave that alone for now. Now this has a different relationship. In this case, c squared is equal to a squared plus b squared, where the other one, c squared, was equal to a squared minus b squared. So here's the good news. So ellipse, we knew it came from a circle, right? So we knew it was x was squared, y was squared, and it was addition. Now, the relationship was c squared is equal to a squared minus b squared. So since the formula had an addition of the x squared and y squared, the relationship was subtraction. With a hyperbola, x is squared, y is squared, but it's going to be a subtraction. Okay? Now notice the relationship is addition. So the addition and subtraction got flopped. So with the ellipse, the relationship was a squared minus b squared, but the formula is x squared plus y squared. Hyperbola, the relationship is a squared plus b squared, but the formula is x squared minus y squared. Okay? So just like the same things that were going on before, we're going to talk about where the center is 0, 0. Now, you see this dotted line here that says y is equal to negative b over a, x, and this here. I'm going to explain how we create those two axes of symmetries. Okay? I'm going to explain how we get those. And B has everything to do with it. Okay? B has a lot to do with it. A and B has a lot to do with it. Okay? Now, before with the ellipse, we're talking about that it's going to go this way if the A was under the x squared. Goes this way if the A was under the y squared, right? With a hyperbola, because there is a x squared and a y squared and a subtraction, that sometimes the x squared term is going to be positive, while the y squared term is going to be negative, or vice versa, where the y squared term is going to be positive and the x squared term is going to be negative. So this is how we determine if it's going to go along the x direction or the y direction. Okay? So here it is. If the x squared is positive, it will open towards the x directions, left and right. If the y squared is positive, then it'll open up and down towards the y direction. So if x squared is positive, left and right towards the x direction. If y squared is positive, up, down towards the y directions. The reason why those axes of symmetry matter is to tell me how I should open up the hyperbola. Because just because you give me a vertex, I can go wide, I can go narrow, because there's nothing that's keeping it bounded or fenced in. The axis of symmetry is what gives me where I can go and where I can't go. Okay? So here the y squared is positive. So notice that the a squared is always underneath the positive one. It always comes first. Always underneath the positive square term. A squared is always underneath the positive square term. Are we okay so far? I think I think like the other ones, information is great, but until we actually get into action with it, with some examples. So again, if the center is not at 0, 0, right, that means the y squared term would just be y minus k squared, and the x term would just be x minus h squared, right? So that's the only difference. Everything else stays the same, so that is exactly what you're going to see here. The top one, since x squared is positive, that means it got to open towards the x direction. The bottom one, since the y squared is positive, that means it got to open towards the y direction. That's all. Okay. Yes, you're going to see this table here. And yes, this is here, but to me, I don't think you need to know it. Because I'd rather just look at the graph and say, what's the equation of that line, of that axis of symmetry? Or the asymptotes, I should say. Sorry. I call it axis of symmetry. I should have called it the asymptotes. Sorry. So let's jump into an example to see what this looks like. So here it goes. So where's my center here? Awesome. Is this opening up left, right, or up, down? Left, right. And the reason why you know it is because of this right here. No, actually. Whoa, okay. That became nothing. Oh, come on. Make a box. So since x squared is positive, you must open in this direction and this direction. Therefore, my a squared is equal to 64. A must equal to 8. Therefore, my b squared must equal to 49. So b is equal to 7. Okay, so let's look at the graph. So I'm guessing there's no questions on what I just did so far. We're good with all that. I know that C is missing, but let's deal with C in just a moment, okay? Because I want to deal with those asymptotes. So we know that 0, 0, 0 is the center. We know that A is going to open left and right, so the A is going to be 8, 2, 4, 6, 8. Vertice. 2, 4, 6, 8. Vertice. And then my B is 7. 2, 4, 6, 7. 2, 4, 6, 7. So with my A and B, what I'm going to have is this. Everybody see that I can create this box right here with my A and B? Okay? That's why all the boxes you saw is because of your A and B. After you draw the A and B is where you're going to now draw a diagonal oh, shoot. That's why this is not doing good. And there goes my asymptote. Can you tell me what the slope of this asymptote is? But think about it. What is the equation of a line? How do I find the slope of a line? Isn't it rise over run? Okay. So let's go from one point to another. What's my rise? What's my run? Isn't that true? Because if I look at this right here is 8. This right here is 7, isn't it? This line right here has a positive slope, doesn't it? The center is at 0, 0, isn't it? So that means the equation of this line has got to be do we understand that? And the equation of this line must be make sense? Yes? And that all came from my A and B. So it's either going to be A over B or B over A, one or the other. Right? But one of them is right, one of them is wrong. So you got to, that's why I'd rather graph it, see it, and going, okay, I see this, that's my run, this is my rise, so that's my slope. Right? Because, let me do this as well. Here's the thing. I can draw this now. Because the graph is going to look something like this. Hey, it's disappearing on me. Okay, so that's how I would graph it. But again, I'm still missing C. So I know that C squared is equal to A squared plus B squared. So C squared is equal to 64 plus 49. So C squared is equal to what? 113? Which is approximately what? So that means 2, 4, 6, 8, 10.6. 8, 10.6. My foci. So my center was 0, 0. My vertices were what? And my foci? Awesome. Not bad? So pretty, isn't it? What do you mean?
Like when I'm doing the homework at home, like I want to like draw like you're doing, but I don't have graphing paper, so I'm trying to kind of like draw on Desmos while I'm doing then it doesn't like connect, and then I get confused.
Well, in Desmos, you just do this. But does that help though?
I mean, it just helps me visualize it more, so I can like, because I can do the equations in my head, but if I don't see it, then I get confused when I'm doing the problems.
That looks a little trippy, doesn't it? I'm just wondering how you would draw that box. You know what I'm saying? Like, how am I going to draw that box in there so that I know, you know what I'm saying? So I see how these vertices. No. What's the equation of a box? I mean, I could put down like vertical and horizontal, right? But then it's going to kind of intertwine with everything. Like, I guess I could, like, no, not that. If I can go, because that would be the box that draws your thing, but kind of just like interrupts the whole thing, doesn't it? Yeah. You could do that. You could. I don't remember how to do that though. Yeah, but the problem with this is that you're limiting it. There is a way of entering this in here to say only go from -7 to +7, right? Because if you do it in here, then it's gonna go like only show this box, right? In here or here. Oh, right here you're talking about. Oh, sorry. This should be 8 and -8. It did not. Oh, it just changes this. I can't remember what it was. No. There is something that you can do with it. I just can't remember what it is. Where you can just shrink it so that it only goes that far. Because I know I did it before with piecewise functions. So there is a way of doing it. I just can't remember what to add into it. But at least even just this way, you can see the key things, right? You can obviously you can always change these to like dotted lines and let's say keep it all the same. And maybe this line here go orange so it's a lot brighter. Oh, there's one that I didn't do. You know, maybe something like that might actually kind of keep everything less distracting. Okay. Oh no! Actually, this is not bad. Right? Do I have to do completeness squares here? No. Because there's not actual x to the first degree or y to the first degree, right? It's still x squared and y squared. It's still subtracting. So what do I need to do here?
Needs to divide by 256 on both sides.
Okay, so all I got to do is divide everything by 256. So this way I have x squared over, what is that, 16?
Yes.
Minus y squared over 256 equal to 1. Because again, I need that right side to equal to 1. My center is at?
0, 0. Oh no, wait. Yeah.
Okay, let's see if this question is going to come up. Does it open left and right or up and down?
Wait. Wait.
Why? Because the x squared is positive. So remember, it's different from the ellipse. Right? The ellipse, we're looking for the bigger number in the denominator, right? And that's my a squared. With this, we're looking at if the x squared is positive versus the y squared is positive. Right? So refer back to this note right here, right? When I wrote this right here. Right? Since the x squared is positive, that's why it opens left and right. See that? Where here, again, since the x squared is positive, it has to open left and right. So a squared is equal to 16. So a is equal to 4. B squared is equal to 256. So b is equal to 16. Oh boy. Hey, stay away from that. Eek. That looks weird, huh? This one happens to ask what's the transverse axis. What did I say the transverse axis is like? The other one is the major. Transverse axis is the major. So it's asking for the major axis. And the major axis involves the foci, the vertices, and the center. So in this case, it's going to be the x-axis, right? Notice how far the foci is. Hey, what are the equations of those asymptotes? So now that you've learned the parabola, the ellipse, and the hyperbola, the question is going to be, so all of these three things are called conic sections. And why are they called conic sections? The reason why it's called a conic section is it all originates from, I'm sorry, not this, but a cone. Okay? It all comes from a cone. So if you think about, if I was to cut this right here, and I was to split it up, you'll see a parabola. Right? If I cut it right here, if you look at the cut section, it will look like an ellipse, and so on and so forth. Okay? That's why these are called conic sections. All right? So it says analyze this conic section to answer the question below. Wow, look at all those questions below. There's no questions below. So the question is, what conic section is this? We have no idea. Actually, we do have an idea.
It has to be either a hyperbola or a
Ellipse.
because the x squared and y is
Oh, awesome. Because the x is squared, y is squared, it has to be either an ellipse or a hyperbola. Can we go further than that? It actually,
It has to be an ellipse.
por qué?
Because if you complete the square,
Even before that, just look at the equation, I should already know. Why should I say is an ellipse?
because both x and y are positive.
Fair enough. Remember, x squared, y squared must be ellipse or hyperbola. If it's addition, ellipse. Subtraction, hyperbola. Yes? So I know there's the ellipse. However, if I had to answer those questions of Where's the center? Yada, yada, yada. I'm going to have to involve here the completing the squares, right? So if I look at this, I got 16x squared minus 224y plus 36y squared is going to equal to negative 208. Oh, sorry. Yes. Ooh, this is going to be interesting. All right. We only have 5 minutes left, so I'm going to try to do this quickly. You guys ready for this? So remember, completing the squares, A had to be 1. You guys remember that? So in order for us to get A to equal to 1, we actually have to do a GCF here of 16. And if I take 16, it'll be x squared. And what's 224 divided by 16, guys? 14. So 14x. Okay? So now you look at this. Again, I'm only focused on this. The rest I'm just ignoring. Everybody see this though? Yes? Okay? So now I can go, great. Is that true so far? Let's see if you guys catch on this. Oops, wrong place. Do we understand why I added 7, 8? Oh, that is not even there. No, that is there. Yeah. Oh, no. Sorry. This is 49. But why did I add 786 on the other side?
Because you still have the 16 that you need to multiply.
Yep. So when I add 49 on this side, I didn't really add 49. I added 16 times 49. That's why I got this. Okay? So you want to put a little note that this is that 16 times 49. So when I wrote 49 here and I'm adding it, I'm not just adding 49, I'm adding 16 times. So whatever that GCF is all part of it. So now I'm going to have 16 x minus 7 squared plus 36y squared is equal to, what is that, 576? Oops. Are we okay so far? Do you guys know what I did? I divide everything by 576. Right? 16 divided by 576, I'm going to have 36 left. 36 divided by 576, I'll have 16 left. And then 1. Is this open in x direction? Or I'm sorry, is this going in the x direction or the y direction? X direction, right? Because with the ellipse, we're looking at where the larger number is. It's under x squared, it's going to open in the x direction. With a hyperbola, we're looking at which one's positive. Right? So we got to be careful with that. So here, center is at 7, 0. A squared is equal to 36. Oops, wrong. B squared is equal to 16. Okay. Oh, that's pretty good. Oops. Yeah. Right? It's, oh, sorry. True? And since class is over, I'm going to let you guys figure out what those points are. The vertices is pretty easy. It's the foci that's going to be more interesting. But again, back to that second example where we said it was the center plus or minus that C. Okay? So, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. I will see you guys next Tuesday. Later.